Welcome back, guys. Hello. I'm back. I promised I'm going to do the complex part of differentiation. So I want to keep my promise. And so that leads us to calculus 1, still on the calculus 1 because we have different complex things in calculus. But the simplest of what we're doing. Some of the techniques used in differentiation. Some of the techniques that are being used to solve some of the complex part of differentiation. Number one is the composite function. The composite function is also known as function of a function, or you'll also call it chain rule. I think chain rule is the most common among the students. Chain rule, some call it function of a function, and it is also called composite function. Now, for instance, we have an example that says differentiate 1 over 3x minus 4 into bracket 2. Permit me to tell you this, that this is not a polynomial question where you have to start, you know, opening the brackets up. No. Why? Because it is acting as a denominator. So the next thing we have to do is to use the composite function. So if your y, I can also rewrite my y to be, instead of this, I have 3x minus 4 minus 2. That is it. So it is the same thing. It's just, using the same thing as 1 over x will give you x raised to power minus 1. So that's just the same thing I did. Now, in this bracket, we have a power function and we have the number itself in the bracket. So what you have to do is to make your 3x minus 4 u. You might want to ask, why didn't we use z, why didn't we use t? Now in this, the only letter I know is u and v, and that is the most common in differentiation. In calculus generally, it is always u and v, and that is why I made 3x minus 4 by u. So if I'm to differentiate my u with respect to s, I have the u over the x to give me 3. And then if my u is 3x minus y, automatically my y becomes u raised to power minus 2. So my dy over du will also give me minus 2u minus 3. At the end of multiplying both, because we will surely do that, the y over du times the u over the x. Now, at the end of multiplying, you can see the u cancels out the du, so I still have my dy over the x. It must still be equal to this. You don't say the x over the u. You say the u over the y. Why? Because we're doing it, this is in respect to the u, while this is in respect to the x. So let's get it straight. But this one is differentiating u, this one is differentiating x. So the next thing to do is to just multiply. My dy over the x gives me 2u raised to the power minus 3 times 3. So my dy over the x gives me 6u raised to the power minus 3. Automatically, this gives me 6. My u still remains 3x minus 4 minus 3. I can also say that my dy over the x is 6 over the same thing I did. That's just it. I just want to make the vision clear enough. Yeah. So this is 6 over 3x minus 4 into bracket 3. I will move to another question talking about the use of composite function. So another question here says, differentiate 2 over the square root of following. So my y, I can still say, is the same thing as 2 over 2x minus 4x plus 9, 1 over 2. So automatically my y becomes, my u, 2x minus 4x, 2x squared plus 9. Then my y becomes 2 over u raised to the power half. It becomes 2u minus 1 over 2. So, differentiating my du with respect to x, I have 4x minus 4. This becomes 0. So the u over the x becomes 4x minus 4. That's that about there. And then, so my du over the x becomes 4x minus 4. My dy over the x becomes 2 times minus 1 over 2, u minus 3 over 2. When you add 1 to half, it becomes 3 over 2. This cancels out this. My dy over the u becomes minus u raised to the power minus 3 over 2. So if I'm to multiply this, I have dy over the x to give me dy over the u times the u over the x. So dy over the x becomes, this is my dy, the y over the u becomes minus over 2 du over the x into bracket 4x minus 4. I can decide to do it like this. Since my u is 2x squared minus 4x plus 9, I'm not opening the bracket. So what you do is the y over the x automatically becomes minus 4x minus 4 simple as that. So that is all about using your composite function. Can we also still proceed? So welcome back, guys. Because there is no time for me to start proving some of these equations, some of these rules, and of which I believe some of us are so much familiar with calculus. And that was why I decided to just do some of these things out. The next rule is the product rule. The same way we have the composite function being used or called function of a function or the chain rule, the same way we have the product rule. The product rule concerns when you have, two elements combined together with multiplication. And the only thing to differentiate such is using your product rule. So your product rule is u, the v over the x, plus v, the u over the x. I believe we'll understand more when I begin to solve some examples. We have to differentiate 3x minus 2 squared plus 3. Now you might decide to ask, I can also open the bracket, just multiplying everything together, you can. But to make sure that your work is simple and neat, just apply the product rule. Instead of going through the polynomial again and start differentiating, just go use the product rule. And now my 3x symbolizes, this is my u, but this is my v. You might want to ask, why is the u coming before the v? Even in alphabetical letters, the u comes before the v, and that is what we'll also follow in mathematics. You don't say yx, you call it xy. My 3x minus 2 becomes my u, while my x squared plus 3 becomes my v. So using the formula that says u, the v over the x, plus v, the u over the x. What is my dv? dv over the x is differentiating the v with respect to x. And that is why we have dv over the x. This is my v. So if I'm to differentiate x squared plus 3, definitely it gives me ordinary 2x. Then my du over dv gives me, if I'm to differentiate this, automatically I have 3. So following this formula, I have, what is my u? 3x minus 2 into bracket of dv over the x, and this is my dv over the x, plus this is my v into bracket of du over the x, that's 3. So opening this bracket, I have 6x squared minus 4x, right, plus 3x squared plus 9. So I can definitely add. This gives me, this is the y over the x. So the y over the x here gives me 9x squared minus 4x plus 9. So that's all about that. Using the product rule. The product rule concerns when there's a multiplication between your elements to be used. I guess we have another example to do. We're asked to differentiate x squared multiplied by 2x minus 3/4. These are confusing technical questions. But I decided to break them down, so when we come across some of those questions, we'll be able to trash them out. So, my u remains x squared. And if I'm to differentiate my u, I have the u over the x to give me 2. While my v is 2x minus 5 into bracket 4, into square of 4. So if I'm also to differentiate this, the v over the x gives me 4 into bracket 2x minus 5, 3. Just your normal differentiation. Now following the rule, the y over the x is u dv over the x plus v du over the x. I have x squared into bracket of this then my v into bracket of the u over x, that's 2. So as long as it is, you might decide to leave it like that. Yeah. So can we also move to the third rule that is being used in differentiation? The third rule is the quotient rule. The quotient rule. Now, I have a question here. The rule is the quotient rule. Now, the quotient rule, unlike the product rule, that's because just like the word implies, product, multiplication. The same way when you have your elements in the division form, the rule to use is your quotient rule. And this is the formula: v du over the x minus u dv over the x, all divided by the v squared. So we have a question here: x squared over root of x plus 1. Naturally, I told us this is our u, and this should be our v. Now, if my u is x squared, automatically the u over the x becomes 2x. My v is the same thing as x plus 1, 1 over 2. So if I'm to differentiate something like this, I have 1 over 2 x plus 1. When you minus 1 from this, you have minus 1 over 2. I'll get it. Now, following the rule, v, your dy over the x, concerning this means v du over the x minus u dv over the x all over v squared. So, my v is x plus 1 raised to power 1 over 2 into bracket du is 2x minus my u s squared, while my dv is 1 over 2 all over right. So definitely I can decide to write this to be like this, right? Minus x squared all over the x plus 1 into bracket minus 1 over 2. I can also write this to be exactly. So we have something like that minus this all over. When you square a square root, you have the original number all over x plus 1. So the next thing to do is to find the square root of this part of this, to find the LCM. So we have this becomes 2x times 2 into bracket root times root. Are you following what I'm doing now? When this one multiplies this, it gives you the original number minus x squared. Not forgetting this first denominator. So we have 4x into x plus 1 minus x squared all over 2 root x plus 1 divided by this original denominator divided by x plus 1. So what we have here is 4. When you open the bracket, you have 4x squared plus 4x minus x squared over 2 root x plus 1 times 1 over x plus 1. Let's keep on following. It's a very technical question. Yeah. So when this minus this, we have 3x squared plus 4x all over 2 roots x plus 1 multiplied by 1 over x plus 1. Now, this automatically becomes 3x squared plus 4x all over 2. Now, the issue there now is this is half multiply, adding up with 1. You know, when you have an indices, you say when a raised to power b multiplied by a raised to power a, we have a raised to power b plus a raised to power a plus b. That's the same thing we're doing here. So everything, the root of x plus 1 multiplied by x plus 1, everything gives us x plus 1, 3 over 2. That is half plus 1 gives you 3 over 2. So I might decide to just, do it like this. 3x plus 4 over 2 into x plus 1, 3 over 2. And that is all about the first question. Let me also try and give us another technical question in which we use quotient rule for. So number 2 says, x plus 1 over x minus 1. Now, this still remains my u, this remains my v, and I'm still using the quotient rule formula. So if u is equal to x plus 1, therefore, my du gives me what? 1. 1 minus 0, 1. If my v is x plus 1, therefore the v over the x also becomes 1. 1 plus 0 is 1. And using my formula, the y over the x is v du over the x minus u dv over the x over v squared. This gives me my v is x plus 1 and the u over the x is 1 minus my u is x minus 1 into 1 over my v is x plus 1, so I have x plus 1 squared. Now, if I'm to open up this bracket, I have the y over the x to be x plus 1. This becomes minus 1. When I open the bracket, I have minus x plus 1 all over. When you open this bracket too, you have x squared plus 2x plus 1. So the y over the x is, this cancels out this, so I have 2 over x squared plus 2x plus 1. And if I do not want to open the bracket, I can still say that the y over the x is 2 over x plus 1 squared, or say that the y over the x gives me 2 into bracket x plus 1 minus 2. So that is all about using the 3 major rules or 4 rules or techniques in differentiation. The first one is the composite function, which is also known as function of a function or chain rule. The second one is the product rule. The third one is the quotient rule. And the fourth one is the implicit function. But unfortunately, I won't be able to teach that now. So I hope that you'll subscribe to my YouTube channel and you'll click on the notification bell so when I do class on the implicit function, you'll also be available to learn from them. See you very soon.